So hello and happy Math Day. This is the third of 4 video primers in which I'll cover some of the essential junior high math skills related to the idea of rational numbers. And so in this video, we'll review the concept of multiplying and dividing positive and negative fractions. So many will find this to be an easier operation to do as compared to, say, adding and subtracting, because we do not have to think about common denominators when we divide and multiply. The process is pretty straightforward and even a bit intuitive, except when it comes to dividing. Where the heck does this thing called invert and multiply come from anyways? Well, we'll investigate that and a few other complications, but always with the understanding that this is a skill that does not stand alone. You do not study high school math in order to learn how to multiply and divide fractions, or even add and subtract them for that matter. These skills are all in service of a higher conceptual mathematics that you'll begin to appreciate even this year. As in with all of these primers, this lesson is meant to be interactive, and you can find a link to the PDF worksheets and the solutions to the practice problems down below. I do encourage you to print these off and follow along as we work through some examples. Math is an interactive enterprise, and you learn best by actually doing, not just by sitting and watching me do the work for you. So without further ado, here we go.
Let's recall from grade 7 that there are some simple rules when multiplying or dividing integers, that is, positive and negative whole numbers. Well, those rules also apply to fractions. The first one is that, well, a positive times a positive or a positive divided by a positive will always yield a positive number, okay? Similarly, a positive times a negative or a negative times a positive. It doesn't matter what order it happens in because multiplication is commutative. That is, A times B is the same as B times A. So the point here is that a negative times a positive will yield a negative value. And that goes for division as well, of course. I don't have room to write down all of the different combinations. And finally, a negative divided by or multiplied by another negative gives you a positive. So it's really important to know and remember these key things, and you see how some of the stuff you learned in grade 7 now comes back at you. And so when it comes to multiplying fractions now, remembering all of this positive and negative interactions, multiplying a fraction becomes very, very simple. You simply multiply the terms in the numerators together, you multiply the terms of the denominators together, and if at all possible, you simplify by dividing by a common factor to make it as simple as possible. So in practice, how does this work? So it's as simple as dealing with the positives and negatives first. We have a positive number times a negative number, so we know that the answer will be negative. And we have 1 times 3 on the top, 2 times 4 on the bottom. And when you simplify that out, you're going to get negative 3 over 8. That cannot be simplified any further, and so we are done. So you notice I like to deal with the positive and negatives first. So a negative times a positive will still give you a negative. And on the top, we're going to have 2 times 14 over 7 times 8. And when you go ahead and finish off that arithmetic, you're still going to get a negative number. You're going to get, what, 28 over 56. And then that final step of simplifying, we have to find a common factor between the two. Well, in fact, 28 goes into both the top and the bottom. And when I do that, I get a 1 on the top and looks like a 2 on the bottom. So 28/56 simplifies into a rather simpler and boring, if I dare say, 1/2. So while we're on this example, let me show you a little trick that you can do that might help you out. It might not be immediately apparent to you, and honestly, this is where students have some trouble sometimes when they can't figure out and identify those common factors up here. So is there a way that we could simplify our lives a little bit from the get-go? And in fact, there is. And that is by looking for common factors across the product. So for example, if I have a 2 here and an 8 here, I know it's a very simple common factor of 2. So I can divide 2 by 2 to give me a 1, and I can divide 8 by 2 to give me a 4. And likewise, there's a common factor in this cross product here. 7 goes into 7 once, and 7 goes into 14 twice. And then this allows you to be a little bit more simple in your first step. It's still going to be negative because a negative times a positive is a negative, but now we have 1 times 2 on the top and 1 times 4 on the bottom, which is to say negative 2 over 4. And that's a lot easier to simplify than perhaps 28 over 56. And looking back at my first answer here, it seems to me that I dropped the negative sign, so there it is. So if you can get your head around what we've done here, that can set you up to solve these kinds of questions with a little bit less fuss and muss. And so on to the third example, which we did out of order. I'm going to start with multiplying out the negatives. Negative times the negative is a positive, and you don't normally have to write a positive. It's presumed, but I like to show it just to demonstrate that I've considered the positives and negatives in the expression, right? All right, so in the numerator, we'll have 1 times 1. In the denominator, we'll have 3 times 3. And when you simplify this, you're going to get 1 over 9. Easy peasy. All right, how do we deal with an integer times a fraction? Well, we deal with an integer by converting it into a fraction. So this is going to be equal to, let's see, a negative times a positive is negative, so there I'm dealing with the sign issue. 4 is the same as 4 over 1. Any integer can be expressed as a fraction, as we've discovered in the first of the 4 primers that you've looked at, where we were converting integers into fractions and vice versa. So negative 4 over 1 times 3/8. And if you want to do the simplification game here, we can divide both a 4 and an 8 by a 4. We'll have a 1 left over there and a 2 left over there. And so we get negative 1 times 3 on the top, 1 times 2 on the bottom. Looks like we get negative 3 halves, negative 3 halves. And it's okay unless we tell you to express it as a mixed number. If you want to do that, you go negative 1.5. Either one of those is okay unless we explicitly ask you to express it one way or another. And in this final example now, we are given the minor complication of multiplying 3 fractions by each other. Now, 3 fractions or 4 fractions or 12 fractions multiplied is the exact same process as multiplying 1 fraction by each other. Let's start with dealing with the sign of the answer. We have a negative times a positive times a positive. That will give us a negative value for the answer. And then let's see if we can't do some simplifications. I think we can. We can take 2's, for example, out of a 2 and out of an 8. You'll have 1 2 in 2, and you'll have 4 2's in an 8. What else can we do? Well, we can take a 5 out of a 5 and 15. And finally, we can take the 3's out of a 3 and a 9. So we've simplified our expression a little bit, and I think it'll make it easier to do the multiplying. Because I don't know about you, but I did not want to multiply 2 times 9 times 15. What I will do fairly easily is multiply 1 times 3 times 3, no problem. And on the bottom, 1 times 1 times 4, no problem. We still have a negative. We'll have 9 on the top. Looks like 4 on the bottom. And if you wanted to convert that into a mixed number, you could easily go 2 and 1/4. Either one of those answers will be acceptable. All right, cool. Well, that was fairly easy. Multiplication tends to be a little bit easier than adding or subtracting just because it's intuitive. You multiply the tops, multiply the bottoms, and simplify. And so a final complication, and why not? The easiest thing possibly is to simply convert both of these into improper fractions and then do the multiplications. And so how do we do that? Well, the first term will be negative. 2 times 3 is 6 plus 2 is 8 on the top and 3 on the bottom. Times 1 times 4 plus 1 will be 5 on the top and 4 on the bottom. And if we wanted to do some simplification, we could do that because 4 goes into... It's just like doing 8 divided by 4 straight up. What are you going to get left with when you divide 8 by 4? Well, you're going to get 2, or 2 over 1, and that's where those come from. And so now this will equal negative. It's all negative because of that. Negative 2 times 5 over 3 times 1. And when I finish this off, we're still going to get a negative, looks like a negative 10/3. Or if you want, negative 3 1/3. All right, last question. Negative a half times negative 4 1/2. Well, the first thing I'm going to notice is the negative times the negative is going to turn it into a positive. That's cool. But let's go ahead and put these into improper fraction, especially that second term into an improper fraction. Negative 1/2 times 4 times 2 is 8, plus 1 is 9/2. And now, so we have a negative times a negative 1/2. Well, 9 on the top, 4 on the bottom, and that cannot be simplified anymore. I mean, you could say it's 2 1/4 if you want, but either of those will work, and we are happy. In grade 8, where you first learned about multiplying and dividing fractions, we worked with you quite a bit to show you why this little trick that I'm about to show you right now works. This thing called invert and multiply. We've been learning it ever since, well, your teachers were in grade school. Yours is not to wonder why. Just invert and multiply. So what do we mean by that? Well, what it means is you take the first fraction and leave it alone, but you take the second fraction, the divisor, and you invert it. So if you've got a 3/8, you're going to invert it and it's going to become 8/3, okay? And then you simply multiply through as normal. Invert and multiply. Well, we did spend time with you in grade explaining why it works, and I'm not going to spend too much time on this because at this point, the technique needs to be 100% bomb-proof with you. It works because dividing a number by anything is the same as multiplying that number by its inverse. That's why it works. Let me show you a couple of quick examples. 6 divided by 2 quite obviously is 3. You know that, there's no magic. But applying our understanding of what division and multiplication are, that is that they are inverse or reciprocal operations, I say that 6 divided by 2 is the same as multiplying by the inverse. Well, what's the inverse of 2? Well, 2, remember, is 2/1. What's the inverse of 2/1? 1/2. All right? And what happens when you multiply this out? Well, 6 is really 6/1 times 1/2, which is 6/2, which is 3. Same answer. All I'm doing here is proving to you that dividing by a number is the same as multiplying by its inverse. Same thing with a messy example like this. 7 divided by 3, well, obviously is simply 7/3. And if you want to put that into a mixed number, 2 1/3. But let's do it using this other understanding. It's not something you're going to do normally because it takes a lot longer. All I'm showing you is that it works. And we're going to use that understanding of why it works later on when we actually divide fractions. So 7 divided by 3 is the same as 7/1 times the inverse of 3, or the inverse of 3/1, or 1/3. And what's this going to do when you multiply through? Well, it's going to give you 7/3, or 2 1/3, just like up there. All right? So invert and multiply works, well, because it does. All right, let's use this understanding and delve through a couple of questions here. 3/4 divided by -1/2 is going to be the same as 3/4 times 2/1. The inverse of 1/2 is 2/1, and it's negative, of course. And so let's deal with the sign first. Positive times the negative will give us a negative. 3 times 2 is 6. 4 times 1 is 4. And that simplifies as -3/2, or -1/2. Example 2, -3/2 divided by 2 2/4. Well, it looks like I have to deal with that first and turn it into an improper fraction. So I'm going to divide this by 4 is 8 plus 10, so 10/4. And then now I can convert this into a multiplication operation by having -3/2 times 4/10. All right. So negative times a positive will be negative. Good. 3 times 4 is 12 over 2 times 10 is 20. And that simplifies quite nicely into -3/5, right? Because 4 goes into both 12 and 20. And do note that I could have simplified a couple of ways. I could have simplified that fraction as 5 over 2. That would have made my life a little bit simpler. All right, negative a third divided by negative a third. Oh, you could do this a couple different ways. The easiest way is by considering any number divided by itself. What is anything divided by itself? Simply 1. Make sense? All right, let's see how we do it the arithmetical way. This is going to become negative 1/3 times, and the inverse of 1/3 would be 3 over 1. All right? And bringing this home, negative times negative is positive. 1 times 3 on the top, 3 times 1 on the bottom, 3 over 3, 1 over 1, 1. All right? So our initial idea that anything divided by itself is 1 can save you time. Negative 2/7 now divided by 1 and an eighth. Let's convert that second fraction into an imperfect fraction. Negative 2/7 doesn't change. 1 and 1/8 becomes 9/8. Cool. And so now a negative divided by a positive will be negative. 2/7 divided by 9/8 is the same as 2/7 times 8/9. And we get negative 16/63 on the bottom. And let's do a couple of last examples, this time at the speed and skipping a couple of steps, which you should be able to do now moving into grade 10. Negative 2/3 is the same as negative 8/3, and we're going to multiply it because we're going to do the invert and multiply in one step. 1 times 4 plus 1 is 5 over 4. The invert of that is 4 over 5. And when we multiply this, negative times a positive is negative. We'll get 32 in the numerator and 15 in the denominator. We're done. 21 divided by 3. What kind of question is that? 21 divided by 3, well, it's 7. Easy. Do it by inspection. But let's do it using the fractions, okay? 21 divided by 3 is the same as 21 over 1 divided by 3 over 1, which is the same as 21 over 1 times 1 over 3, which equals 21 over 3, which equals 2. Yay, 7. Just demonstrating again that invert and multiply, converting things into fractions works, whether or not it's the easiest way to do things. All right, 2/3 over 1 over 3. 2/3 over 1/3. This looks confusing, but if you rewrite it as 2/3 divided, because that's what that means, by 1/3, I think it's less confusing. So 2/3 divided by 1/3 becomes 2/3 times 3 over 1. The 3's divide out, you get 1's in their stead. You're going to get 2 over 1 or 2. Now, I want you to be able to look at this question and see that it makes sense. 2/3 divided by a third. In other words, how many 1/3s are there in 2/3? How many 1/3s in 2/3? 2 of them. Just like this question up here, this question might be easily done by inspection, but I want to show you that when you do the algorithms of dealing with fractions, that you also get the same answer. And that's kind of the beauty of math. It doesn't matter how you attack it. Sometimes there are 2 or 4 or many different ways of getting to the same answer. Negative 5/7 divided by 10 over negative 3, okay? Once again, it's probably simpler to rewrite this. Negative 5/7 divided by, now the negative is in the bottom there, but the negative can go anywhere you please in a fraction. Now don't write this down, but I want you to know that 10 over negative 3 is the exact same thing as negative 10 over 3, which is the exact same thing as 10 over 3. All of those forms of the fraction are numerically equivalent, and it doesn't matter where you put the negative sign. So why don't we put the negative sign where it makes it easy to deal with, in front. Negative 5/7 now divided by negative 10/5. Well, first thing I'm going to do is deal with the sign of the answer. Negative divided by negative is positive. 5/7 times, now we're going to invert 10/3 to make it 3/10. 1 times 3 is 3 on the top. 2 times 7 is 14 on the bottom. 3/14. Now, I've set you up with a series of practice questions. The answers are in the answer key, which you'll find in a link down below somewhere. Just a few examples to get you going. But on the last page, on page 4, I've given you something that looks really, really weird and wonderful. And I want to spend some time. I just want to solve this first of the practice question. We'll call this an example, and then let you go at those 2 examples there. All right? Because this looks scary. So if I were going to talk this out, I could say that this is 1/4 divided by 2 times 2/3 divided by 1/4. So something divided by something divided by something. And that could be a bit scary. So how should we approach this? Well, let's use the trick that we used in previous examples, which is to rewrite the fractions as divisions. All right? 1/4 over 2 times 2/3 can be thought of as being 1/4 divided by, let's convert 2 and 2/3 into an improper fraction, 8/3. And then you have another division sign here, so we're going to further divide it by 1/4. That's what we get when we rewrite the question using mathematical symbols and not fractions. Well, how do you deal with this? Well, you're going to have to remember the rules of BEDMAS, because I want you to know that A divided by B divided by C is not the same as A divided by B divided by C, right? It's why we have BEDMAS, that rule that tells us the order in which to do operations. And BEDMAS tells us that when we have multiplication or division, you do them in the order in which they occur. So implicit in understanding BEDMAS is knowing that you're going to do this division first, and then you're going to continue. Now, can you tell by looking at this that this is what you're doing? I'd say no, and I'd say that it is an artifact or a problem with the math software we use to create these problems. If we wanted one division to be overruling, if we wanted one division to be the more important division, then this question here would look like that, with the larger fraction line above the 1/4. If, however, we wanted the converse, and don't write this down, I'm just doing this really quickly, to represent 8/3 like that, then we would write the original question like that. Do you see how that makes a little bit of sense? Do the stuff under the bigger fraction line first, in other words, the parentheses, and then finish off your question. All right, so let's move forward then. 1/4 divided by 8/3 is the same as 1/4 times 3/8. And, we don't have to do it first, but let's invert and multiply that second fraction there. 1 times 3 is 3. 4 times 8 is 32. Now times 4/1, and that is going to give us what? 3/8. Okay. So we've gone from something that looks kind of scary to an answer that is actually pretty intuitive, step by step. You've got the skills. You just have to break the question down and perhaps rearrange it, restate it in a way that makes it more clear to you what you're doing. So looking at these examples, I think that in this one we give you, it's pretty obvious that you're going to do everything above the fraction line first and divided by -4 after is the last thing. So that should be pretty simple. This question here might not be all that straightforward. You got to decide which one to do first. Is it this or is it this? And I'll leave it to you to try to decide which it is. The answers will be posted down below. Give it a hack. Even if you make the wrong choice, you're still going through the operations and learning and reminding yourself and practicing how to divide fractions. So give it a try and see if you made the right choice. And that's it with our third lesson on rational numbers. Go hit those practice questions. Go check them against the solutions. And happy math.